guys. Please welcome our next speaker, Ranjish Rajaram from Red Hat, who will answer a question about what should be a PID1 in a container.
Yeah, thank you, Julie. Hi, guys. So today we will look at what should be the PID1 inside a container. Right? Okay, so this is what I have. So the first few slides, I would try to use them to build and drive my point about what should be the PID1 inside a container. And during the session, I will try to move towards some shell. I will try to execute some commands to show you some outputs. Right? So let's begin. What do you understand by the term namespace? Anybody? Yeah. Okay. So namespace, in a very simple way, it actually abstracts a global resource so that the processes within a namespace thinks that it has an isolated global resource, right? So it is just an abstract of a global resource. So here we are more concerned about the PID namespace. So what's a PID namespace? So a PID namespace is nothing but it's process ID, right? So it actually abstracts the process ID in such a way that the containers, like multiple containers, would have the same process ID, right? So it just abstracts the process ID of the host, and then the processes which are running inside the containers, they would have the same process ID. But from a host perspective, that process ID is actually mapped to a different actual process ID. And when you start your container, the first process which is started in that particular namespace gets the process ID as well. Right? So if you start a process inside a container, that container would get the process ID as well, right? As the PID1. And so if a process is, a clone or created using the clone command with the flag clone new PID, that particular process gets the PID as well. Okay. So that's about the process PID namespace. Now let's look at how do we start, how do we control which process should have the process PID as well. So we have a Docker file, correct? And we actually use the CMD or the command. So we have 3 different ways to start a process, and the process which are started can be the PID1 inside the container. Right? So the first option that we have, which is the most preferred way. So this is how we start a container. For example here, so this is just an example of how we start an HTTP container. So this particular format is known as the exec format. Right? And next the next option that we have is using the CMD, we can actually pass some parameters to the entry point. Right? So now what's an entry point in Docker or in a container? Okay.
The entry point is the big one, right?
Sorry, I didn't get that.
You're asking what is the entry point?
Entry point.
So that's the, if there's no other entry point defined, then it's HTTP here, but it's a B1. Right?
Yeah. So entry point is nothing but if you don't have a CMD or if you don't have anything, if you just start a container, so that is what it executes for you. Right? And so if you use the CMD parameter, you can actually pass some variables to the entry point. And the third option is you can just start a script, or you can actually do an shell exec. That is, if you just say CMD space echo, so first it starts a shell and then it runs the echo command. Okay. So this is the first example of a simple container that we are going to see. That is, you're just basically installing HTTPD and then you're just starting it. Right? So when you run the container, so this is the process that should start. Okay, and next we have a very simple example of using the third option of CMD. That is, we are just starting a script. Okay, that is, we are just starting a bash script, and maybe you could write some ifs and buts, and you could do some logics. You could actually find what is the environment variable that is being passed. Based on it, you could take some action. So here we are just, just for the example's sake, we are just showing you a simple example of top command. Okay. So first container is about you're starting it using the most widely used option of an exec format or a JSON format, in whichever way you actually want to call it. So here we are just starting an HTTPD process, and for the second container we are just starting a bash script, and within the bash script we are actually calling our process, which is top. Okay. So now let's see what happens. So when you start the container, right, here the most important thing that you would see here is, so when you use the option command, so this particular process, that is your first HTTP process, gets the PID as 1. Clear? And when you use the second option of using a bash script, so here what you see is bash becomes your first PID. Okay? And your actual process top is actually a child of the bash process. Right? So this is just, again, just to reiterate. So in the first option, we actually used HTTPD, and we used this option of CMD. So here, this particular process becomes the PID1. So this is the most widely used format, and this is what you would generally see if you take any Docker images from Docker Hub or from anywhere. So this is what you would see. And in some cases, also you would also see like they start a bash script, and within the script you would start your actual process. Okay. Now let's look at a simple example of C and see what would, is this a really big a thing that you should take care, like which process should be the PID1 here. So here we can see that this HTTPD as a PID1. Here we see top, so the bash as the PID1. So now let's take a simple example, and I'll just show you some command outputs, and then let's decide and think which process should be the PID1. Does it really matter? Okay, so again, a very simple examples, right? So this may not be the right way or the best practices, because I just not want to use more space. So I just made it two more, like two commands. Right? So here what we're going to do is, we have the same Python-based web application, right? Here we are using the first option, that is we are starting the process directly. Second, and the second container, what we're going to do is, we're going to start the shell script and then call our actual Python process. That's the only difference. Okay. So in the first container, we are calling the Python-based application directly. The second container, we are starting a shell script and then we are calling the Python-based process. Okay. So we will come to it a bit later what it means here, but at this particular point of time, we are going to use the same application. We're going to build two containers. In second container is just that we're going to start a bash script, and then the bash script is just going to start the Python program. Okay, so I already have a container built, so it shouldn't take much time. Yeah, so we'll start the first container. Yeah, so we started two containers. Here you can see the command. Here we are starting the application directly, and here we are starting a bash shell, and then we are calling the application, right? So now let's access the application, right? So the same, we'll just try it like a couple of times and then change the IP to the second container, right? The output is same because we are running the same application in port 8000, and we're getting the same output because the application is same. It's just that we are just changing how it is running. Right. So now the most important thing. So the first container where we are calling the application directly. So what do you see here? You have different processes. Right? So here we have the PID1 as this particular application. Right? And we are seeing a different processes. Now same application in a different container where we have the bash as the PID1, and here you see there is no different process. It's the same process. We are running the same process here, right? But when you access this particular application, you are seeing some different processes. But on the second container, where you're starting using bash and then you're starting the Python script, you're not seeing any different processes. Okay. So now it is important for us to keep in mind, like, we should actually decide which process inside the container has to be PID1, right? Because here the behavior is just different. Here is the Python process is PID1, but here the bash is the PID1. Right? So let's see. So now, what's the role of PID1? So in a general Unix system or in a Fedora, the PID1 is actually with systemd, right? That's the init process. So this particular process, PID1 has many additional roles to take care of. So one of it is process reaping. That is, if there's a different process, it is the responsibility of PID1 to clean that process from the process table. So let's imagine if you have a container and that container has a lot of different processes, and at some point of time you would have multiple instances of the same container, and one point of time when the load goes high, you would have more different processes on your host system, right? And what would happen? Okay, so let's go back to the okay, so let's imagine. So from the host system, right? So from the host system, when you execute the command ps, you can actually see the different process. Because these processes in the host also take up a process ID. So this is the actual process ID. Right? So when you have so many different processes, at one point of time, your PID's process table entries, that is the maximum that you can have is 32,768. But it is, you can actually change it on the fly. But there's a limit that's been set by default is 32,768. So if you have more processes which are in different state, they take up one entry in your process table, and a process which is in a different state would still consume a PID. Right? So when you have more different processes at one point of time, there would be no more free process IDs which can be assigned to a process. So you may or may not be able to log into the system, or your containers may not be possible to start a new process. Right? So it would actually go into a hung state. Right, so PID1 has an additional role of process reaping. Right? Now what happened to the other container where you have the bash script as the PID1, or the bash shell as the PID1? Right, so this bash shell has an additional property where it can actually reap its children, different children. Right? So just to go back and show you that. Yeah, so here, we are not seeing any defun process because bash is the shell with the PID 1. So it means that bash has an additional feature where it can actually read defun processes. Right? So is bash the answer for this problem? Answer is an yes and a no. Let's see why it is a no. Yep. There's a huge issue. The problem here is bash may not properly pass the the sig terms or the signal to the process that is actually running. Right. So the moment bash receives the signal, it will kill itself. But it may not pass the exact signal to the processes that are running. Right. So imagine if you have a DB application or an application which has a lot of memory in the cache and which is not at sync. If such a process is there and if you're trying to stop a process, the signal doesn't go directly to the actual process which is running. So it can leave your process in an inconsistent state. Okay. So you actually have one more workaround. So this is what we are doing here. Right? We are just making sure that we handle that signal. Right? So process. So here, what we are trying to show you is the process should also register as signal handler. Okay, process should also register its signal handler and trap the signal. Make sure that all the child processes are killed and then it exits. Right? So I just have 5 more minutes, so let me. Okay, so let's go back to the example and let's try to kill the process and see what's happening. So we'll stop the first container, right? The first container is the container which actually has the defun processes, and it is just an Apache process. Okay. So I'm doing a Docker stop. So Docker stop, what happens when you execute a Docker stop? So here you can see it's taking a lot of time, right? It took around 10 seconds. So what will happen is that when you execute Docker stop, it sends a sig term and waits for the process to kill itself and exit in a graceful way. But that doesn't happen because you have some processes which are in defun state. Right? And then what Docker does is after a 10-second timeout, it sends a sig kill. Okay? Now let's stop the other container. Yeah, so this was fast, correct? Now let's look at the exit status. Here you see 143 and 137. So it is 128 plus 15. So 15 is for sig term and 9 is for sig kill. So if you add 128 plus 9 or 128 plus 15, this is the value that you see here, right? So here we can actually say the first container was sig killed, right? And the second was stopped using the sig term. Right? So it is important for you to have the signals that you pass while doing a Docker stop should be handled properly. Right? So if you have a process inside a container that doesn't handle the child processes well, or if it doesn't handle the sig terms or the sig kills or the signals that you pass, then you have to make sure that the application that you write is written properly to handle them, or you should register a signal handler. Okay. Let's go back. Okay, so what do we have as an answer? You could find many such Docker pages in the internet, like a dumb init or minimal inits like Tiny. So they actually have very less code, just enough to start your process and handle the signals, right? So when you start using a dump init, this is what happens. So this is how the hierarchy would be. First you start a dump init, and then the dump init starts your actual application. Right? Since out of time, let's go to the next most important point is, can you have systemd inside a container? Right. So with Docker 1.12, I believe, it is possible to run systemd inside a Docker container without using the privileged option. Okay, so you can have a systemd inside a container without using the privileged option, right? And with the new features like the OCI hooks, right? You can actually register the system and take care of many other things, because whatever is needed for a container to start in a non-privileged mode, that sort of that feature is actually provided by the OCI hooks, right? So the moment you start a systemd inside a container, the OCI hooks actually detects that and mounts certain things for you, so that you can actually run a systemd inside a container in a non-privileged mode. Okay, so so now the additional benefits. Okay, I think I'm out of time, so let's open it up for questions. So I'll just show you quickly. So this is a systemd container, this one. Okay, so this is systemd container which is running, and right. So if I execute machine CTL, so with the OCI hooks, it actually registers your container to the machine CTL. Now the advantage, as I showed you, as I mentioned in my slide, that you actually get an additional benefits of logging, right? So if I so by default, what happens when you execute Docker logs, it actually prints the output of an application if it writes to std error or std out. So what about application that actually writes to the syslog? Right? So when you put an application inside a container, you start thinking about how to handle the logging. So if you have systemd inside, you can actually bypass that particular functionality back to the systemd. Okay, and if you already have a system init file, let's say for Apache, you can just use it. Right? You could so when you build the container, you just say systemctl enable the particular service, right? Yeah. So this is the logging that you see for your. So from the host system itself, you can actually see the logging using the journalctl command. So any application that writes to the syslog can be taken back to the host system, and you can actually see them. Okay. So any questions? I'm already out of time. Yeah.
Are there any caveats concerning Linux?
Linux? No. Yeah, but you should always test, right? That's pretty much the answer. You shell the answer for solving the process raping, yes or no, because you have to test it. You have to make sure that the process signals are properly processed and is stopped in a proper way. And if you have noticed in a Docker file, you can actually define the signal that has to be used using the stop signal directive. Let's say for Nginx, it doesn't really work well with the sig term, right? So you can actually define the signal that has to be sent using stop signal, right, in the Docker file. Or when you use Docker stop, also you can actually pass the sig term or sig kill, whatever you want. Yeah?
Are you using default systemd installation in your container?
Yes.
Any additional packages?
Yeah, I'll just show you my default. I'll just show you the Docker file. So it's on RHEL. Yeah. So I'm just using the systemd package that comes with the RHEL 7 platform image or the container image, right? So the only line that I'm using here is, so I'm just adding my service and then saying systemctl enable. Yep. So last question. Yeah. Can you repeat the question, please?
Is it possible to run systemd in upstream Docker, or I have to make some registries or my
So right now, the example here that I'm showing you is actually on a Fedora 25 system. So on an upstream, I think you should be able to run because it is again part of runc. Docker uses runc now. Now all the OCI hooks makes use of that runc. So you need not do anything else. Yeah. So thanks, guys. So thanks for